Hey class. So just to follow up from the last video, the stories that I gave you about exponential functions. There's two things I do want to talk about before we continue with the lesson, and it has to do with exponential growth and exponential decay. So going back to uh, exponential functions, and remember, exponential functions is in the form of y is equal to a times b to the x power. Um, if you had a chance to saw the video that I asked you to watch, there's two cases. We got exponential growth, or we can have exponential decay. So exponential growth, and if you had a chance to look at some graphs, they normally look something like this. Here's my axis. So for exponential growth, they tend to look in this form. And for exponential decay, the graph, let me label my axis, tends to look something like this. So we'll talk about what the reason for that is. Um, but again, looking at exponential growth only. So again, the function looks like this: y is equal to a times b to the x power. This component b is what we call the let me make sure I use the right term from the book. It has different names. It's called a constant factor. So this is what we call the constant factor. And if b is greater than 1, then we're going to have growth. And I hope you saw that on that video that I posted for you to watch. And for exponential decay, again, the function looks like this: y is equal to a times b to the x power, again, where b is the constant factor. So if b is between 0 and 1, then we're going to have decay. So again, depending on what this is, if it's greater than 1, then it's going to be growth. And for decay, again, depending on what b is, if it's between 0 and 1, it's going to be decay. So that determines what the the graph is going to look like. So I just want you to make sure you understand that part. Now what we're going to do next is we're going to look at exponential functions in real life. So I'm going to show you something that you're probably very, very familiar with at this point. And what we're going to do right now is pretty much what the book does. After this, it just shows applications of exponential functions. So I'm gonna start with this graph. So again, it's probably something you recognize. Notice that uh, this graph, I got it. The source is from the John Hopkins uh, CSSE. So this is, I'm showing you where I'm getting this from. Let me show you the website so that um, you have a reference point. And notice that, this timeline, notice that it's not, it stops at the 28th, March 28th, because I was looking at this last week, but I'm pretty sure that if I refresh this page, I'm going to have something more current. And they started gathering data starting January 22nd. So based on this graph, January 22nd, there was only one case. Then January 23rd, one case. So if I click on this, uh, February 30, 11 cases. So then we see um, what the data looks like. So I'm going to gather some points from this graph, but I'm going to start here at March 5th. March 5th, there was 217 cases. March 6th, 262. March 7th, 402. So I'm not going to use all the data points. I'm just going to use a few of these. And then I'm going to use decimals to do exponential regression. So I'll remind you about regression in a minute. But if you look at this very clear, this data right here, it's exponential. It's an exponential function. So the question would be like, well, if I see this exponential function, how can I come up with the function equation that generates this graph, this data? So that's what we're gonna do next. So again, in starting with uh, March 5th, so I'm gonna write that in my graph right here. So this is back to my decimals graph. So I'm gonna start here at March 5th. So this is gonna be my first point. And then I'm gonna use the 6th, the 7th, the 8th, the 9th, the 10th. And I'm gonna stop here. So I'm gonna choose at least 10 points uh, to generate a table in decimals. So this is what we're gonna do. So we're gonna go to decimals. And I'm going to choose choose 10 data points, and then I'm going to create a table. Once I have my data points, I'm going to use remember we did linear regression in decimals. We're going to use exponential regression to find the function that generates the data. So just a quick reminder, linear regression in decimals was like this. Remember y sub 1 is, remember, tilde congruent to m x sub 1 plus b. But this time we're doing exponential. So for exponential regression, this is what we type in decimals, okay? It's again y sub 1 tilde congruent to a times b to the x sub 1 power. Okay, so I'm going to show you that in decimals. Remember, you can always go back and watch the video so that you can do it yourself. So I already have the table in decimals. So again, As you saw on the website, every time I click on this, it would give me the day and how many cases we had. So I did my, the work already. Um, so here's the data that I have again, starting with March 5th. So I'm calling that day one. So day one, there was 217 cases. Then March 2nd, which in this case is day two, they had 262 and so on. So here's um, using that graph, and here's the data that I have. So notice that it looks I can see that it's not linear. I can see it's forming up a curve. So my question is this: how do I generate the function that goes with this, the exponential function? So again, have your notes handy. So if I want to find the equation for this, the function, so I have to use a exponential regression. So y sub 1 is congruent to a parentheses b to the x sub 1 power. So there it is. So notice that now I have, and I'll make this predictor mode. So notice that I have my equation now. So I know what A is equal to. I can see it right here, and I know what B is equal to. So let me type that in here. So that means that the function will be y is equal to, so I see that A is 117.9. I'm gonna stop there. But if you want to write down all the, I'm going to round it up to the nearest tenth. But if you want to write all the numbers, that's fine. Parentheses. B is 1.31. 1 point. Oops. Put 1.31 to the x power, close parentheses, and notice that there is, so it's very similar. Notice that it's not completely accurate because I rounded off my numbers, but it's very close to it anyways. So let me take a screenshot of this. Oops. And let me just put that in our notes in Notability. So there it is. So I use that data, and I use Desmos to generate to type in the same data, uh, and I use Desmos to come up with the equation for this. So again, where did I get my a from? So when I did my exponential regression, I saw what a is equal to. When I performed exponential regression, I saw what b is equal to, and all I had to do was put it in here on my second line to come up with the function. So now I know what the function is. So notice that in this case, in my table, uh, x represents, so it doesn't show here, but if you look at the meaning of the axis, I'll type it in here in the graph. So notice that here x has a meaning and y has a meaning. So if you look at what I said previously here, x is very clear, it represents the date or the days. And very clear that y has a meaning. Y in this case has the meaning of the number of cases. So now that you hear, if you're watching the news and you say about, you hear when they talk about how do they know how many people they're expecting to get sick a week from now, 2 weeks from now, 3 weeks from now. Well, they're looking at the pattern and then they come up with their functions, and that's how they're making decisions. So now you probably have a better understanding of why we have all these restrictions, because we don't want this curve to go really high really fast. So when you hear the term of lowering the curve, this is what they're talking about. So this is where I'm gonna stop. So you're gonna have an assignment that is based on what I just did. I sent you a message, and like I said, if you have questions about this, send me a message and I'll reply back. Of course, you're gonna have to submit this work, and it's gonna be graded. Remember, everything that I assign as of now, it's gonna be graded on the it's gonna be on the it's gonna be graded, and I will keep you posted on anything that we have done before. My advice is this: stuff that I assigned before we have to leave school, you have to complete. So again, it's not late to do any missing or late work. Make sure you do it. Upload a picture, and I will be grading it. I know that you guys are sending messages about any great work that you've been submitting is not graded yet. I will get to that for sure. Uh, but again, make sure that you're completing all the work because you're gonna be held accountable for that. So there's no excuses. So again, this is where I'm gonna stop. And if you have any questions, send me a message. Guys, stay safe and stay